Good evening, ladies and gentlemen out there in social media land. This is Dr. James Lyons-Weiler coming to you live from WWDNYK studios in Pittsburgh, Pennsylvania. And I am trying my best to do my very best Rand Paul impression, quarantine face, and I need a haircut, but these are super trivial things to talk about. So today on Unbreaking Science, we are going to be getting into the science of coronavirus, and you're going to be able to help if you want to. So let's get started. All right, so some of you are very familiar with my contributions to the coronavirus situation. Early speculation led to a hypothesis that perhaps there was a laboratory origin, and then I did some science and I tested the hypothesis and I falsified the hypothesis, which means that I convinced myself that it probably wasn't of laboratory origin. Like every couple of days, I get a message. I either get an email or I get a message on Facebook or other elsewise on social media, in which somebody says to me, "Hey, look, this Nobel Prize winning scientist Luc Montagnier, or this other person over here, or look, I found a virus and I think that it might be, it's laboratory made and it's a chimera that looks like a smoking gun." And I'm not going to go over all those details because what I want to do is I want to take this in a very different direction. There's something very important that you can do to help, and I'm going to explain how we've set up a competition of sorts in Ipak, um, and take a break from my gardening today to sit down with you and say, this is what I found. This is how you can do it. And if you find a match, then you're automatically, and I verify it, then you're automatically entered to win a $500 prize. It's IPAC money from donations from the public, and I'll go over the rules at the end. But first, let's take a look at what I'm talking about here. At the IPAC website, there's a report entitled Motif Pathogenicity Typing. SARS-CoV-2 coronavirus may contain a unique, likely pathogenic protein motif signature, also found in a natural isolate from 2005. And the interesting thing is, I submitted this for peer review in a journal that should have wanted to publish it, and they came back with, "Hey, you know what? We don't know anybody that thinks that this was built in the lab." Unbelievably, so I just decided to publish the report. And in that report, let's see, where am I? In that report, uh, I actually go through in great detail here, um, the actual findings, where there's a phylogenetic analysis that shows the relationship between SARS-CoV-2 and all the other viruses that were in the database at the time. Now, this is now, gosh, got to be a couple of months old. But the important thing is that the spike protein that people are talking about in SARS, there's a report out this week by someone, I don't know who authored it, but they said, look, Fauci owns a patent on a spike protein. HIV has a GP120, and there's something about 120 spike proteins on SARS as well, and that makes it into the same protein. Well, I was contacted today by someone, and I actually did the motif typing, and the HIV surface protein, glycoprotein, is completely different than SARS-CoV-2. So when you see that, please don't share it because it's just wasting a lot of time to go through this. But what I want to do is I want to show you what these boxes mean down here in the pathogenicity, and I'm actually going to teach you how to do the analysis if you want to do it, to the best of my ability with the platform that I have here. But basically, most coronaviruses have a motif pattern that is different from SARS-CoV-2. And when we get down to the nitty gritty of what it looks like, there's a table in the report that you're going to look at. And these are the accession numbers of the proteins that I studied for that report. And the table actually outlines which sequences that were published at the time that had what their motif pattern looked like. This is a motif pattern that is typical of coronaviruses, beta coronaviruses that are not SARS-CoV-2. And by that I mean SARS mostly. Um, and the details to pay important attention to are that it has a long N-terminal domain here. That's a motif, right? And it has a SHE3 that shows up. It has a KXDL, and there's no GP. I think it's 42. Let's take a look. GP 41. Sorry. Whereas compared to the SARS-CoV-2 motif, it's a very different configuration. It's stark. It's black and white. The SARS-CoV-2 spike protein is actually simpler. It has a short spike 2 and terminal domain. It does not have a SHE3. It does not have the KXDL, and it does have this GP41. Those I'm saying are characteristic. So if you go back and forth here, there's no GP41. There's the KXD that's there, but it's not in the other one. And here's the SHE3, and it has a longer N-terminal domain. Now let's go back again. See the short N-terminal domain? All right, so the short N-terminal domain, the presence of the GP1, and the absence of those other two. This is very different between these two. And this helps me think that maybe SARS-CoV-2 was actually, simpler and in its domain arrangement and potentially in its function. So before I get into the details of that, I want to show you exactly how to do this. So if we can go to the first thing to do is to go to the NCBI's protein database. And I'm going to try. I can barely see what I'm typing in this that I have here. But SARS, if I can type, oh, I can't type. Well, anyway, you go here and you type in SARS-CoV-2 up in this box, and then you hit the search. Okay, and you'll get an accession number. And then what you do is you then go to a motif software, which I have to look up. Okay. Yeah, you go to a motif software that brings this up, and I'll bring that page up here in a minute. It's from Japan, and it's computational identification of protein motifs. It's a very, very simple software. Yeah, here it is. So I just have to add this resource. From the NCBI protein database, you'll find any coronavirus that you think is related to SARS. Excuse me. And there is an accession number. This database is a national database, and there's an accession number associated with proteins. So if you're looking at, I don't know, a research paper, and they're talking about a chimeric protein from years ago, or if you're looking at a patent, and there's a NCBI protein accession number in the patent. If you come across any research on a protein that you think, hey, I should write to Dr. Jack and find out if this protein is actually maybe the one, because it's chimeric. It was, they said that they added this feature in the lab, and maybe, it's a SARS and it's a coronavirus, and maybe it's the one. Maybe it's the one that they modified and, the backbone, so to speak, and they added features to it. Or maybe this is where they got the spike protein from. What I'd like you to do is I'd like you to go to this and find the accession number, and then you have to get find the protein file, and then from that protein file you select the FASTA, FASTA format, which is just a text format, and then you're going to literally cut and paste on your clipboard. So this is ideally done on a computer, but you can do it on your phone. I've done it on the phone. And what you'll do is you'll just paste in the protein sequence itself of the spike protein. It's the spike glycoprotein. Sometimes it's called the S protein. And then you hit run. And when you hit run, it only takes 2 seconds of analysis for it to characterize the protein motif patterns. And then it'll give you a report Let me see, I'm trying to find that. Yeah, it'll give you a report that either matches this, and it'll have the blue bars here. So what this diagram is this is the amino acid location 0 all the way to 1200. HIV, the spike protein is much, much shorter than this. It doesn't have this. I did the analysis today. The HIV surface glycoprotein is nothing like this at all. But nevertheless, it'll have the short N-terminal domain. It'll have the GP41, and it won't have the KXDL, and it won't have the SHE3. Or it'll look like this, or it'll look like something else. Either way, there's thousands and thousands of viruses as a result of calls, including my own calls, for people to sequence coronavirus samples that are in their labs. There's no doubt that the Chinese got scared probably and destroyed samples. Those are the reports coming out of China. So we might not have the actual smoking gun, but I think it's well worth characterizing which proteins, spike proteins that are in the databases match the SARS spike protein. Frankly, guys, because I don't have time to do it, I'm doing the Vax Done Vax study. I'm writing a bunch of articles. I'm working with Chris Shaw and things. I'm working with other people. And I've already done it. I've written a report. I already went through those that were published. Now there's a bunch more that are published, and I need your help. So this wasn't as good of a tutorial as I would like, but I'll put point-by-point instructions on the Ipak website with screenshots so that you can see exactly how to do it. Also, if anybody wants the slides here, you can see the specific instructions. Here's how to participate. Number one, find the COV protein amino acid sequences at the NCBI protein database or a similar resource. Using the FASTA format that database gives you, submit the sequences one at a time to the Japanese motif resource. And I give you the link here, genome.jp/tools/motif. Very simple. And then if you find a protein motif pattern that matches the upper image, that is the one that I showed you, that would be this one. Okay. If it matches that, I want to know about it. And if I can verify, then what you should do is you should send me, report the matches to info@ipaknowledge.org. Make sure you include the amino acid sequence protein database accession number. Post your findings on Facebook if you want to and tag me on it. And this was the announcement earlier today. This is my Unbreaking Science episode to demonstrate this tonight. All verified matching entries will have a chance to win a single prize of $500. There's no entrance fee. Employees of Ipak nor relatives of employees from Ipak employees can participate. And you can try as many amino acid sequences as you like, and this is so simple. If you can cut and paste on a computer, you can do this analysis. Don't participate if you're not allowed to do so in your state, county, city, or country. I need your help because I simply don't have the time to put into the brute force analysis of thousands and thousands of sequences that are out there. And in this community science, if we could actually find other ones like the SARS-CoV-2 that I found, that was a SARS-CoV-2 that was published in 2005, but nobody knew that it was SARS-CoV-2. The Chinese thought that it was SARS. Ralph Barrick from the University of North Carolina downloaded it. His team downloaded it. They thought it was SARS. They have a publication based on it in 2008. This whole report tells that whole story. That we have the spike protein way back in 2005. Now, what does that mean? That means it's probably from nature. This sample that it came from was a sample from the anus of a bat. But I'd like to know if other laboratories had it, if other laboratories have been studying it and didn't know it, and that they thought they were working on SARS and they were actually working on SARS-CoV-2. I think this is the fundamental, most important scientific contribution that I've ever made, and they wouldn't publish it because they didn't know anybody that had contemplated that the virus was created in a lab. And that just shows I'm a month ahead on all these issues. I've been a month ahead, and I need your help. I'm ahead on testing. Everybody thinks that, oh my, if you say testing, it means mandatory testing, and that some way Bill Gates is going to be involved, and that the government's going to have your information. I'm ahead on testing because antibody testing is a route, for me anyway, to be able to walk out that front door and go do whatever I want if I'm already immune. So what do they say? Oh, it doesn't mean that it's immune. Bullshit. Of course it means that you're immune. There's like 1.8 million people that have recovered from coronavirus, from COVID-19. Well, how did they recover if their immune systems aren't working? Doesn't make any sense. So their agenda is to shut down testing where you know the results, but your doctor doesn't. So you're empowered. You know the results, but the government doesn't. So you're empowered. The patient's always the last one to know. And they want to do mandatory testing. And now Jay Inslee out in Washington's threatening to not let you go grocery shopping. Grocery shopping. You're not free to leave your house to go get food to sustain your family. Is he bucking for an insurrection or something? I mean, these are fundamental rights. Now he says, okay, they're going to have a group of people that are going to ask you what you need and make sure you get what you want. No, thank you. No, thank you. I'd rather privately test myself, know what my status is, and make my decisions about if I need help from my family. If I'm going to do something on my own, I want to know my results because I don't trust the government to not, hardwire fascism, hardwire totalitarianism, where they're telling me, okay, for coronavirus, you have to be tested. For coronavirus, you have to have this vaccine. For coronavirus, you have to have this medicine. What's next? Okay, you're over 65, so to prevent Alzheimer's, you have to have this drug. Or you're 4 years old, and you're going to go to school, so you have to have the psychotropic meds. If we allow them to codify, the medical government that we have, the medical fascist government, if we allow them to codify where they're in the decision-making process over what we do, and I've told you dozens and dozens of times when I went around the country on tour, I said that vaccines are not the main game. The main game is getting drugs into your body. This is how they're doing it, folks. So we need to have basic knowledge about which viruses are out there, where this thing came from. No, I still don't think that it was made in the lab. I think Luc Montagnier is incorrect. I haven't seen a publication from him. If someone has a publication, send it to me. I need to know the exact subsequence that he thinks was an HIV insert. The HIV inserts that were published by that Indian team, those are random matches that could have occurred by chance alone, statistically. I don't mean my opinion. I mean, their analysis showed that it could have happened by chance alone. They made a big deal out of nothing. They said it was uncanny similarity. It wasn't uncanny similarity. I took a friend of mine through the analysis and showed them that with random sequences of amino acids, we generated random sequences of amino acids in real time. You can get matches to HIV. You can get matches to anything if you blast against it with short sequences. So listen, join in with us if you've got some time and you really want to learn how to do it. The instructions are very, very, very simple. I'll go over them one more time. You don't have to do the phylogenetic analysis. You're probably not going to be able to do all that. But basically, go to ncbi.nlm.nih.gov protein and search for the SARS coronavirus, search for any beta coronavirus, and then use the FASTA formatted amino acid sequence. It's a string of letters. There's with a minor code on the top, and submit it to the genome.jp tools motif tool. And then if you find a protein motif pattern that matches right here, then you're golden. Now you can see this motif pattern also on this article here on my browser. I mean on my blog, where I wrote this article that shows the two protein motif patterns. This is the one of SARS-CoV-2, and this is the one of other beta coronaviruses. All right. So anyone that has this right here, this larger, more complex motif pattern, is not related to SARS-CoV-2. It's a more distant relative. And I appreciate any help that anyone can give me, and help the community too. And if we find enough of them, maybe I'll write up a publication. You can get a co-author on a publication because you did the analysis. I have to verify the analysis, but it's very straightforward and simple. And if you want more information, the link and the link on the instructions on how to do this, and you want these slides, write to info@ipa-knowledge.org, and I'll email them to you. I appreciate your attention on this matter, and I'm going to go off and do some more science.